Okay. Good evening. After the class. Good evening, everybody, and welcome to ECE 442. What happened to my class? How come it's strong? Okay. Anyway, I don't care. No, I don't want that. Let's go back to here, and let's continue our discussion. Okay. So what happened? What do I need to push? Which one I need to push? ECE?
The one that's red. The red one.
The red one?
Yeah, it's working. It's working.
Red one is closed.
It's on.
Oh, it's already there? Yeah. What red one? I don't see any red one.
There's a button, if you press it, it'll turn red now because it's on.
Okay, anyway, as long as it's on. Where? Show it to me. What red one?
I think this, yeah,
Oh,
the third one.
Okay. Good. So let's continue our discussion from last time. Let's spend about 2 minutes reviewing what we learned last time. We were talking about SRAM. So SRAM stands for what? Static Random Access Memory. Why do we call it static? Because the data is stored as a what? Either VDD or what? Z. Which means what? It has a path either to what? VDD or a path to what? Z. It does not depend on a charge on a capacitor. In a minute, by the way, after we finish with this one, not in a minute, in about half an hour or 45 minutes, we will go to the DRAM. The DRAM, the data is stored as a what? As a charge on a capacitor. Clear in here? No. The data is either have a path to VDD or what? Ground. Or to the ground. Now, let's look at a typical cell. This is a typical cell. What do you see? First of all, I want you to... Can somebody remind me next time I bring a pointer? Can please somebody remind me? Do you see this back-to-back? Is this a back-to-back inverter?
Yes.
That's a back-to-back inverter. Yes or no? Yes. And we do have two access transistors, Q5 and what? Q6. Yes? They are controlled by the what? The word line. Yes? What is the word line? The word line is the output of the raw decoder. Remember the raw decoder? This raw decoder. Let's look at it one more time. That's a raw decoder. Do you see row 1, row 0, row 1, row 2, row 3, and so on and so forth? This is called
Laser.
What is this?
Laser. Pointer. Top button.
No, this is complicated. You have to understand, I am an old-fashioned guy, Stone Age. So you are trying to show me some new tricks? Next time I will bring a ruler or a pointer, not like digital stuff, just regular one.
Professor, by any chance did we switch our papers?
He doesn't have the
Yeah, I
Did not take, huh?
He needs it, not me.
I think we accidentally switched the...
Because you took my copy.
I have...
Okay. Everybody got a copy of? By the way, I don't think we are going to get into this lecture. We are going to get it next lecture. But I made copies. Can you pass it, please, to the young lady in the back? Everybody got a copy? Okay, good. We are not talking about the CAM right now. We are still in the SRAM. We need to finish SRAM. Then what? DRAM, then the what? The CAM. Clear? But the CAM is very interesting. I think you will enjoy it. So we will see it in just a second. Okay, this is the decoder. Yes? The word lines are these. And the word lines are going to control the what? The access transistors. Which is what? The Q5 and the what? Q6. Did you get it or not?
Yep.
Notice fine. That word line will activate this cell, the next cell, the next cell, all the cells in the same what? In the same row. They are all connected to that word line. Did you get it or not?
Yeah.
So all the cells are going to be activated in a row, but not all the what? column. Do you see those two columns? The bit line bar are what for each cell. In other words, this is one cell, another cell here that has another what? Bit line and bit line bar. But what do they have in common with this? They have the same word line. Did you get it or not? So when you activate the word line and you activate the bit and the bit line bar, you are selecting what? One cell only. Did you get it?
Yes.
Good. Now, let's understand the thing here, first of all. This is a pass transistor logic. It's an NMOS. So when you have a 1, that NMOS will be what? Will be on. Did you get it so far?
Yes.
If it is off, what do I have? If it is off, in other words, if the word line is what? 0, what do I have? I don't have this, and what do I have? A back-to-back inverters, which is a latch. Did you get it or not?
Yes.
Which means what? There is no change in the state. Whatever is stored is stored. Did you get it or not? Yes or no? This is the back-to-back. Where is this? This is the inverter. Who is the input to this inverter? Is the output of this inverter. Who is the input to this inverter? Is the output of this inverter. Now, let's put this one Q and this one what? Q bar. Clear so far? Q and Q bar. Clear? Okay. Now let's start first of all with what? Read operation. Did we start with the read last time or with the write? What did we start with? Read or the write?
Read.
Read. So, read operation. And let's assume the data stored is a, what did we assume last time? Is a 1. What does that imply? It implies Q is equal to what? VDD and Q bar equal to what? 0. Did you get it?
Yes.
Yes or no? Okay, good. Now before I continue, before I show you the steps, I need to make it clear to you. This bitline B and bitline bar, there is no inverter between them. Did you follow me or not?
Yes.
It's just a terminology, bitline and bitline bar. In other words, is it possible this one is VDD and this one is VDD?
Yes.
Possible or not possible?
Yes.
Possible. There is no inverter between them. Did you get it or not?
Yes.
Can you write this in your notes? There is no inverter between what? The bitline and the bitline bar. Clear so far? Okay, let's continue. What is the read operation? What is the first step? The first step, step 1. Recharge. The bit line and bit line bar to anywhere from VDD over 2 to what? VDD. Did you get it or not? Pre-charge them. Question. How are we going to pre-charge them? I will show you in a minute. Did you get it or not? How are we pre-charge them to VDD? I will show you in a minute. Just take my word for it right now. Clear? Good. This is number 1. So what is the voltage here? VDD. What is the voltage here? VDD. Question, by the way. Are there cells below this one? All the cells in a column are connected to the same what? Bit lines. Yes, but they are connected to a different what? Word line. Keep that in mind. Did you get it or not? One more time. All the cells in a row, they are connected to the same what? Word line, but they are connected to different what? Bit line. all the cells in a column, they are connected to the same what? Bit lines, but they are connected to different what? Word lines. Clear so far? Good. What is the voltage here initially? VDD. What is the voltage here initially? VDD. By the way, I'm taking the upper range. Doesn't matter. Doesn't matter. As I was showing just, you can take VDD over 2. Doesn't matter. Did you get it or not? That's the first step. Second step, assert the word line. What does it assert mean? Assert means what? I.e., word line is what? VDD. Did you get it or not? Notice, by the way, this is not the same as what? Pre-charging. This is the output of the decoder when the input is what? Let's assume this is row 0. Yes? When the input to the decoder is what? 0, 0, 0. Did you get it? Last time we discussed it. Remember, all the word lines are pre-charged to what? 0. The word line that I am selecting should remain what? Sorry, all the word lines are what? Pre-charged to what? 1. And then what? Only that word line is to remain what? 1. And the other word lines needs to go to where? 0. Because I'm selecting this NOR base, active high. Did you get it?
Yes.
We discussed this one last time. Okay, what will happen? M5 and M6 are on. Clear so far? Yes or no?
Yes.
However, M6 does not conduct. Why? I'm still waiting. Does not conduct any current. Any current. Why? I'm still waiting. This is what? BDD. And this, by assumption, is what? BDD. Which means the voltage difference between them is what? 0. So there is no what? There is no movement of the what? Electron. By the way, is the channel still there? The N channel. The N channel. Why? Because, by the way, who is the source? Who is the... Huh?
Doesn't matter.
No. This is, at the beginning, this is VDD, this is VDD. So it doesn't matter. Are you following or not? But where is the VGS? VGS is either this or what? This. Did you get it? No response. Did you get it?
Yeah.
Okay. Does not conduct any current. This one, initial. Are you following me or not? Question. Could it conduct current initial? If what? If I am going to pre-charge the bit line and the bit line bar to what? VDD over 2, which I will show you next shortly. Let's finish with VDD. Do you agree this one does not conduct?
Yes.
So go over here. What is this? VDD. Yes? What is this one? 0. What will happen? Current will go this way. Remember, this one is working. Yes or no?
Yes.
Who's the drain? Who's the drain? The bit line bar. This is the drain. This is the what? The source. Because the source initially is what? Ground. You follow me or not?
Yeah.
Notice, by the way, in this case, do we need to take body effects into account? Yes, we do. Although in the exam I will tell you ignore it. But you need to take the body effect here. Clear? No response. Clear? Okay. What will happen? By the way, is there a capacitor here? There's a capacitor. What do we call it? CBL bar. Agree? This is much greater than what? The capacitor here. There's a capacitor here. Did you get it or not? Okay, let me sketch this. You are not looking at it carefully. Let me sketch it again. This is what? M5. He calls it Q. Q5. And what is this one? Q1. Clear? No response. Clear?
Yes.
Question. Why I don't consider Q2? I'm still waiting.
Because it's on.
Why I do not consider Q2? What is the initial Q? 1. Off. Did you get it or not? But is this one on? Yes or no? Initially, is it on? Initially, is it on? Yes, it is. But it does not conduct any current. Why? Can you tell me why?
Because it's voltage.
What is the voltage here?
Zero.
What is the voltage here initially?
Zero.
So the voltage difference between the drain and the source is what? 0. No current. But is the transistor on?
Yes.
The transistor is on, but it's not conducting any current. Did you get it or not? No response. Yes or no? Which means where are we? In the characteristic, where are we? We are at the beginning of which region? Triode region. Remember the triode? Here. Where are we? Initially, here. Which is the beginning of what? The triode region. Yes? The transistor is what? Working, but the current is how much? 0. Because the voltage difference is what? 0. Agree? Okay. What will happen? I want you to tell me what will happen. This is the bit line. This is the what? Bit line C, bit line bar. What will happen? The charge will go from here. Where? Here. Did you get it or not? The current begins to flow. This is I5. Clear? Now we will get whether it's in saturation or triode in just a second. Are you following me so far or not? Yes or no? Okay. One more time. Who's the drain? The bit line bar. Yes? And who is the source? This is the source. Are you following me or not? Now, the capacitor begins to charge. This capacitor begins to charge. When it charges, what happens? This one is on. Why it is on? Because the input is what? VDD. Why is the input VDD? Show it to me. You see this Q? Yes? And this voltage is trying to build up. Are you following me or not? So there is a current in here. I1. Clear so far? Yes or no? Notice, by the way. So there is a current here, I5. Some of it will go in here, and some of it will go in here. Did you get it? Yes or no? Some of the current coming here, and some of the current coming here. Now listen to me carefully. This voltage cannot, or the capacitor, cannot charge more than what? VDD minus VTN. Why? Because the NMOS passes a weak one. Where is this one we are talking about? When I say weak one, what one? One. The one that is what? On the bit line bar. Did you get it? However, I do not want the capacitor to reach VDD minus what? VTN. Why? I want you to see why. If this capacitor here keep charging, what will happen? This voltage will exceed the inverter threshold voltage, which causes this inverter to switch. Are you following me or not? What does that mean? Show me how will it switch? How will it switch if this voltage across the capacitor, which is this voltage, if it goes higher than the threshold of this, what happens? This becomes what? On. This becomes what? Off. And the Q goes to where? Which means what? I changed the stored data. This is supposed to be which operation? Read operation. You are supposed to read what is the stored bit, not changing it. Did you get it? No response. Did you get what I just said? This voltage, the capacitor, when it charges, should not exceed the voltage across. C should not cause, which transistor? M should not cause M3. By the way, what is initially M3? On or off? Why? Why it is off? What is the input? Q bar. Q bar is what? 0. Did you get it or not?
Yes.
So M3 is off. I don't want to switch. I don't want M3 to switch. Do you follow me? In other words, I want it to remain what? Off. Did you get it or not? The voltage across C, Q bar, should not exceed or should not cause M3 to what? Switch to on. Clear? VQ bar should be less than what? VT. Of what? Of M3. Did you get it? No response. Did you get it? What is the VGS of this? VGS. This is the S, ground. VG depend on this voltage. I don't want VGS to be what? Exceeding the VT. Which means what? I don't want to create a channel. You are losing me here.
No.
I don't want to create a channel here. Which means what? The voltage between the gate and the source has to be less than what? VTM. VT, sorry, VT, I said VT. By the way, is there a body effect here? No, why? The body is what? Grounded. Did you get it or not? Yes or no? Okay. As long as it does not exceed, what do I want the capacitor to behave? I want it to stop what? Charging. Yes? So where is the current going to go? The I5, where it is going to go? The capacitor stop charging. Yes? At equilibrium. Where is the I5 going to go? It's going to go to what? I1. Did you follow me or not? So at equilibrium, I5 is equal to what? I1. Capacitor, CQ bar, stops what? Charge. Clear? No response. Clear? Okay. What is the mode of Q5? Remember, what is the voltage here? VDD. Yes? The voltage here, very small. Yes or no?
Yes.
Which means VDS is very large. Did you get it or not? M5 will be in a which mode? M5 is in saturation mode. Yes? Yes? What about M1? Why? Why? It's correct answer. Triode. Why? Look at this diagram.
The VDS is very small.
Is this voltage high or low?
Low.
Low. But it's greater than what? 0. So the VDS is what? Is less than VGS minus VT. Did you get it? M1 is in what? Triode mode. At equilibrium. What do I mean by at equilibrium? When CQ bar stops what? Charging. At equilibrium, I5 is equal to what? I1. Did you get it? No response. Did you get it?
Yep.
Oh, what is I5? Give me I5. In saturation mode.
1/2.
1/2 Kn.
W over L, and then loss.
What do I write here?
VGS.
What is VGS? Look at the M5 and tell me what is the VGS. It's the voltage. This one minus this one. Remember, this is the source. Did you get it or not? The current is going this way. So this is the source. Is what? VDD minus what? VQ bar. Yes? No response. Yes? And then what? Clear? Yes or no?
Yes.
Question. Should I take body effect here?
Yeah.
Here. Should I take the body effect? Yes, I should take the body effect, but I will ignore why I should take it.
Because
That's the source. The source is no longer grounded. Did you get it or not? The source is no longer grounded. Which means what? This should include the body effect. But again, in the final exam, I will tell you what, ignore. Clear so far? Yes or no?
Wouldn't Q bar be grounded because Q1 is
What
on?
Q bar? This one?
Yeah.
Q bar is charging.
But Q1 is grounded. It's on, and that's
Q is this one, which means this one is on.
Yeah. So wouldn't Q bar be grounded through that one?
It's in the triode mode. It's not in the saturation mode. It's in the triode mode.
It's on.
What do you mean on?
Like it's conducting. Q1.
I got that, but this is in what?
Uh,
This voltage here is what? Is the result of the capacitor.
Yeah.
Are you following me or not? What is this voltage? It's the voltage across the what? Capacitor.
Yeah.
Not sure, did you get my point? You didn't get my point.
No.
What is the voltage here?
Is Q. V-
No, here, in this diagram. What is this voltage? Is it the same as this voltage?
Yes.
Which means what? It's not going to change. That's the voltage across the capacitor. Capacitor stopped what? Charging. It holds on its charge, whatever it charged.
Yeah.
Did you get it or
Yeah.
not?
Yeah.
Yes or no? Good. Now, what is I1? I1 is in the triode mode. What is it? By the way, put this one 5. W over L5.
Kn.
What is it?
Kn.
Kn prime.
W over L. 1.
What should go in?
VGS.
VGS. What is the VGS? For M1, what is the VGS? What is the voltage here? VDD. So it's what? VGS minus what? VT. Body effect or no body effect? No body effect. Times what? What should go in here?
VDS.
Which is What is the VDS?
VQ bar.
VQ bar. Question, do I put 0 here?
No.
No, why? This is not initially. This is at equilibrium. Did you get it or not? So VQ bar is this not the same as what? And then what?
Minus 1/2 VQ bar.
Close the bracket. Did you get it? No response. Did you get it?
Yes.
Okay. Now, what do I want VQ bar? Let VQ bar VT. Of which transistor? Remember, I don't want VQ bar. I don't want what? VQ bar to exceed the what? The threshold of this transistor. Why? Because if it does, what will happen?
Switches.
This one will be what? On, which means what? You are going to change the state of the memory. Did you get it? This is a read operation. Read operation is not supposed to what? Change. We say read operation. Read is non-destructible. This is probably misspelled. Non-destructible means what? You are not going to change it. You are just reading it. Clear so far? Yes or no? Okay. You equate those two. Clear? The final answer is this one. It tells you what? W over L. 5 over what? W over L. 1 should be what? Less than or equal to what? 1 over 1 minus dt over what? VDD minus VT,
Squared.
the whole thing what? Squared minus 1. Did you get it?
Yep.
Yes or no? Yes or no? I want you to look at the last equation. Do you see VQ bar? But here, do you see VQ bar? So what happened? Instead of VQ bar, what did I plug? VT. Because I don't want what? I don't want VQ bar to go more than what? More than VT. Did you get it? Yes or no? Now what happened? So tell me, how do I read it? How do I read the bit?
VQ passes VT.
What? What did I pre-charge this line? The bit line? The bit line bar? Sorry, the bit line, what did I pre-charge it to what? VDD. What did I pre-charge this one to? Also VDD. Is this one going to change?
No.
Why?
No current.
There's no current. There's no current here. This one is not going to change. How about this one? Is it going to change? Up or down?
Down.
Down. Why? Because some of the charge will transfer from this capacitor to this capacitor. Did you get it or not? How much? How much did it go down? How much is the threshold of this one? Roughly 0.2, 0.3 volt. You follow me or not? This one will go roughly around what? 0.2, 0.3 volt. Which is enough for the sensor amplifier to what? To detect it. To detect a voltage difference. A sensor amplifier, which I will show you in a minute, is a differential amplifier. What is the difference between the voltage here and the voltage here? Zero. At the end of the read cycle, is it still zero? Is it positive or is it negative? Negative. Sorry, is it positive or negative? Positive. Why? This one remained VDD, but this one went down a little bit. So the bit line minus the what? Bit line bar Is it positive or negative? Positive. The sensor amplifier will what? Will say that what is stored is a what? Is a 1. Did you get it? No response. Did you get it?
Yes.
Yes.
Okay, let's assume that what is being stored is a 0. Can you tell me the procedure? Exactly the same thing. In other words, this Q is what? 0. Q bar is what? 1. Can you give me the procedure? Exactly the same as this one. Pre-charge to what? BDD both. This side does not conduct. Why?
That's a 1.
BDD, BDD. If we assume Q is 0, are you following me or not? But this side will what? Conduct. Did you get it or not?
Yep.
Which means what? What is the differential? Will it be positive or will it be negative?
Negative.
Will be negative. What does the sensor amplifier do? Sensor amplifier will declare that what is being stored is a what? 0. Clear so far. I will show you the sensor amplifier in a minute. Did you get it so far?
Yes.
Okay, question. Could I have charged the bit line and the bit line bar initially to BDD over 2 instead of BDD?
Yes.
I could have. Yes? What happened? Can you tell me what happened?
They both come back.
If both of them are pre-charged to what? BDD over 2. Both sides will what? Conduct. What happened here? Can you tell me what happened?
This is the Q1.
Remember, what did I assume?
Q's 1.
What is being stored is a 1. Which means what? This is what? BDD. This is what? BDD over 2. So what will happen? Current will go this way. Yes? What happened to this line? Go up. How about this one? What did we say? Q is 1. What is this? 0. What? And this one is what? BDD over 2. What will happen? Current will go what, this way? Yes? What happened to this line? Goes down. So one line goes up, the other line goes what? Down. Did you get it or not? I'm going to jump the gun and I want to show you the curve for a sensor. We'll get to the sensor. So let me just show it to you so that you understand what I'm talking about. This is, by the way, the sensor amplifier. I'll explain to you in a minute, but I want to show you the curve. Help me. Initially, what is it? VDD over what? 2. The bit line or the bit line bar. Yes? At this point, what happened? The sensor sent what? Increase rather than what? Decrease. Did you get it or not? If he sends increase, what does he do? He jump into what? VDD. Which means what? He declared that what is being stored is a what? 1. If it decreases, he what? Goes to 0. Declare that what is being stored is a 0. Did you get it? Yes or no? How much does he need? He needs only delta V. This delta V is roughly between 0.2 to 0.3 volt. Are you following me or not? He doesn't need to see a change of what? VDD or 0. He only needs to know the change is what? Positive, small positive, or small what? Negative. Then he will what? Amplify it to what? If it is small positive, he will amplify it to 1. If it is small negative, he will what? Take it all the way to 0. And I will show you how. I will show you in a minute when we get to the sensor amplifier. But did you get this? Everyone? Okay. This is, by the way, if we charge it, pre-charge to what? BDD over 2. Why did I assume here to pre-charge to BDD? Why? It becomes easier to analyze one part of the circuit than what? Both parts of the circuit. Do you agree?
Yes.
Do you agree? Analyze one part of the circuit. Why? Because the other part is not going to work. Yes.
Which one is more desirable?
Which one is more what?
Desirable?
It's VDD over 2 for a reason is to make sure that this one and this one are what? Are matched. And when you start with VDD over 2, this delta is even what? Smaller. Did you get it or not? Then what? Then if you start with a VDD. But as far as the operation of the sensor amplifier, it doesn't matter. Doesn't matter. One of them is because he's differential, which means what? He's taking the difference. Do you follow me on that? So in here, in our case, what did we say? We said that this one is a pre-charge to what? VDD. Is it going to change? When you're reading, when reading, is it going to change on this side?
No.
It's not going to change. Why? Because we assume that what is being stored is a what? 1. It's easier to analyze the circuit. Did you get it or not? It's easier to analyze the circuit. Although when they actually build it, most of the time they pre-charge it to VDD over 2. Clear? Take less time. Take less time to pre-charge to VDD over 2 rather than to pre-charge to what? VDD. Do you agree? Remember, by the way, this capacitor is much larger than this capacitor. Why? This capacitor is the result of what? All the cells in a given what? In a given column, because they are all in parallel. And when you do have capacitors in parallel, the equivalent, more or less? More. Clear? Can you tell me how long does it take for the sensor amplifier to sense the difference? How long does it take? Let's see. What do I have? Let's see if you can help me here. I don't consider this side. Why? Side, no change. Yes? So what do I have? C delta B. What is this C? PL bar. Yes? What is it equal to? I delta T. Where did this equation come from? This equation, capacitor, what is the relationship between the current and the voltage? It's I equal to what? C dV by dt. Did you get it or not? So if you bring dt here, and you take what? An infinitesimal amount? Yes? What is the delta T? Which I is this?
The total coming from.
I'm still waiting.
Coming from the bit bar.
Huh?
Coming from the bit line
No.
bar.
Where is it? We gave it a name.
I5.
I5. What do you mean? Oh. Where is this capacitor? This capacitor is here. Yes? Okay, the charge is going through what? I5. You follow me or not? So what is delta T? CBL bar. Yes? Delta B over what? I5. And this delta B is around what? 0.2 volt, around this 0.1 to 0.2 volt. Very small change. Did you get it or not? In other words, if VDD is 1 volt, what is this one? What is the voltage across the capacitor? The change. We go from 1 to what? Point what? 0.9 something, 0.98 and so on. Did you get it? No response. Did you get it?
Yes.
Very small voltage. And the sensor will pick it up. Clear? I will show you how it picks it up in a minute. Did you get it? Okay, good. Now the right operation. By the way, reading a 0 is the same thing. Do you agree?
Yeah.
No response. Do you agree? Okay, but in this case, what? In this case, if there is a 0 here, if there is a 0 here, what do? I take this one, yes, and this one will not what? Will not conduct, assuming that this one is what? BDD. Why? This one's BDD. What is this one? BDD, which means what? There is no voltage difference between them, no conduct. This one conduct. Which transistors would I then look at? I would look at this and this. Clear? Will M4 be in the picture? Why? Look at the input to M4. M4, the input is what? Q bar. And what did I assume? What is being stored is a 0, which means Q bar is a what? 1. That NMOS is off. Did you get it? Okay, good. Now the right operation. By the way, the right operation is destructive. That's the whole idea about right. Did you get it or not? The whole idea about right is to what? To write on top of what? What is being stored. Clear? You notice, by the way, we don't know what is being stored. Do you agree? In other words, if I want to write into the memory a 1, do I need to know what is in the memory? I don't need to know what is in the memory. If it is in my memory is 1, then nothing will change. Do you follow me or not? If it is 0, then it will be what? Replaced by a what? A 1. Did you get it? Okay. Now, let's assume. Assume the data stored is a what? A 1, i.e. Q is what? VDD, and Q bar is what? 0. Yes or no? Okay. And we want no. You follow me so far? No response. Do you follow me so far? Okay, help me. We want to write a 0, which means what? I need what? I need to make sure somehow this back-to-back inverter switch. Did you get it or not? Because initially what it was holding 1. I want to write a what? 0. What is the step? Step. Set BL to 0 and BL bar to what? VDD. You notice, by the way, it's not this. See, this one, it looks like there is an inverter between them. But in the previous case, there was no inverter between them. By the way, in both cases, there are no inverter. You are just setting the bit line to 0, the bit line bar to what? VDD. Question, why did I set the bit line equal to 0? Why? Because I want to write a 0. You write on a bit line, not on the bit line bar. Did you get it or not? Question, let's assume what is being stored is a what? Is a 0. And I want to write a 1. Can you tell me how do I set the bit line? Bit line is what? 1. And bit line bar is what? 0. Did you get it or not? The data that you want to write should be on where? On the bit line. Let's see what happens. Let's see what happens. So what is initially, one more time? I need to bring this one down. What is initially? Q. I put the 0 here. Yes? I want you to tell me what do I want. First of all, is your current going to go here?
Yes.
It is going to, by the way, and what is the Q bar? Q bar equal to what?
0.
Remember, what is stored is what?
1, 1, 1.
What is the Q bar?
0.
Which means, what can you tell me about this one?
On.
On. Do you follow me or not? So the current going this way, let me show it to you. I'm showing you the what? Which side is this?
Right.
The right side, right hand side. We'll get to the left hand side in a minute. Right hand side. What does it look like? What is this? CQ? Yes? Initially, what is it? Initially, what did I assume? The data is what? BDD, which means what? This one initially stored, BDD. Okay, then what? What is this? The word line? And what is this? Bit one. And what is this? No. Agree. No response. Agree. What is this? One more time. This is M4. And what is this? M6. Clear so far?
Yes.
Yes or no? Now I want to sketch the left hand side. Show me the left hand side. Okay, Q equal to BDD and Q bar equal to what? 0. I'm still waiting.
PMOS is off.
Huh?
The PMOS is off.
This one? Yes, this is the red line bar. What is this one?
CBL bar.
C, big line bar. Yes? What is this? M what?
5.
5. Yes? And what else?
PMOS is off.
Remember, what did I assume?
So 1.
Q is what?
VDD.
1. Yes? Which means what?
It's on.
Q1 is on. So. Clear so far. What is this? One more time. What is this? BQ bar. Clear so far?
Yes.
Now answer me the following question. Please listen to me. Bit line is what?
0.
Remember, I want to write a what?
0.
What do I put on the bit line?
0.
What do I put on the bit line bar? 1. Which is this one is 1. BDD. Yes? What will happen? What will happen is exactly the what? what we saw in the read operation, yes, with one major difference. What is it?
You're gonna exceed the threshold.
I want the cell to what? Switch, which means I want the capacitor CQ bar, yes, to exceed what? The threshold of this one, so that the cell, what? Switch. You lost me here. Did you lose me here? But I cannot do it. Why? Can you tell me why? Because I already what? Sized it such that this voltage does not exceed the what? The threshold of this one. You totally lost me. You lost me here. I can tell. Can we take a deep breath? I want you to tell me what is the operation here. The right operation. The right. What did I put here? 1. What is this initially Q bar? 0. Which means what? Will there be current going here?
Yes.
Which means the capacitor begins to what? Is that the same as the read operation a moment ago?
Yes.
Is it the same?
Yes.
With one major difference. What is the major difference? In the read operation, I did not want the voltage across the capacitor to exceed what? The threshold of who? Q3. Why? Because the read is supposed to be what? Non-destructible. Did you get it or not? But and I sized the transistors. Which transistors? M5 and M1 accordingly. Are you following me or not? Can I change the size based on the write on read? Can I go back and forth? Of course not. Did you get it or not? Why is it different than the previous case? In here, I want this voltage to exceed the threshold of this one. Can you tell me why? So that this one, what? Operates, pulling what? The Q down. Remember, I want to write a what?
0.
I want to write a 0, which means what? The Q is supposed to be 0. Clear? This contradictory requirement between the read and the write tells me what? You cannot achieve what? Both of them. We already sized this part based on who? Based on the read operation. So when we go to the right, I cannot resize it again. Did you get it or not? No response. Yes or no? So what do I need to do? On which side do I need to work? I need to work on this side. Did you get it? Yes or no? Let's see if you can help me. So I want you to look at this side. Clear? One more time. What is the BL?
0.
0. What is the CQ? Initially. 1. Why? Because what is being stored, assume, yes? Sorry, what is being stored is a what?
1.
Is a 1. Can you tell me what happened to the capacitor? It will begin to what? The current will begin to flow this way. You follow me or not?
Yes.
Okay. Then what? This one is also on. Why is this one on? Can you tell me why is this one on? Q bar equal to 0. So there is a current here, there is a current here, and the current will come here. So this is I6, this is I4, this is what? ICQ. Clear?
Yes.
No response. Clear? Okay. What do I want the capacitor to charge to? I want the capacitor. Which capacitor? This capacitor, which is this one. Yes?
Yeah.
To what? Discharge. Is it discharging? Discharge to what? To a value which exceed what? What? Which threshold of who?
The first inverter.
Which one?
PMOS.
Remember, I want to switch this up. What was Q bar initially?
0.
0. What do I want to make it? What do I need to do?
PMOS.
I need to make sure that this one comes what? On. Which means what? I want, remember what is the input to this one? Is a Q. I want this capacitor to charge up to the value which will cause this one. Did I say to charge?
This will make Q.
I'm sorry, I meant what? Discharge. Remember, initially it was what? VDD. I wanted to discharge all the way to the what? To the absolute value of BTP, this one, such that this one turn on. Did you get it or not? And if this one turns on, the Q bar will switch. Clear? And then what do I want the capacitor to? I want it to stop what? Discharging. Did you get it or not? At equilibrium, what do I have? At equilibrium, I'm still waiting. I4, I6. The capacitor stops discharging, i.e. CQ stops discharging. You follow me so far or not? Yes or no? Help me the most. Remember, by the way, this one is what? VDD, this is source, this is a PMOS. Yes?
Yeah.
And the drain is very what? Very small. Why? Why? Because the capacitor has what? Discharge, not to 0, but to a what?
Small.
A value, small value, which is just enough to what?
Turn Q2 on.
Switch this one. Did you get it or not? So which mode is M4?
Saturation.
Huh?
Saturation.
Saturation. M4. Yes or no? Can you tell me what is the M6?
Saturation.
Let's see. What did I pre-charge the bit line to? 0. I want to try 0. Which means what? The bit line is the what? Is the source. This is the drain. Current is coming here, but this voltage is small because the capacitor has what? Discharged. So the VDS is what? Small. Which mode are we? Triode. M6 is in triode mode. Clear so far? Give it to me. Give me I4 first. I'm still waiting.
1/2
1/2.
KP prime. W over LP
Yes. Continue.
times VGS.
What should it be? V is in the saturation mode. VGS. What is the S? VDD. What is the G? Q bar, which is 0.
So VDD.
Yeah, oh, sorry, VDD. Yes?
Yes, yes.
No response.
After the discharge.
VQ bar? No, after the switch.
Yeah, after the
After the switch, what is VQ bar?
1 VDD.
What is initially? What did we assume?
Storing 1.
VQ Initially, what is VQ?
VDD.
1, which means what? What is VQ bar?
0.
0.
And after the switch.
Yes? No, this is before switching. The switching is done at equilibrium. Did you get it?
Yeah.
Okay. So what is the voltage here?
0.
0. What is here?
VDD.
VDD. So what is it? VDD. Agree. No response. Agree.
Yes.
Why did I put absolute value? Because PMOS has a negative threshold. Clear? What is I6? I'm still waiting. Okay, first of all, who's the drain? What did I put in the bit line? 0. Q initially 1. VDD, which means this is the drain. Yes? No response. Yes? Okay. But this one, when I talk about the triode, means what? After this one has discharge, which means the voltage here is no longer what? VDD. Did you get it?
Yes.
Help me. I'm still waiting.
1/2.
Why 1/2? It's in the triode one.
Kn prime.
Yes?
For this, is that for?
No. 6.
6.
Help me. VGS. What is VG?
VDD.
VDD. What is the S?
0.
So what is it? Is there a body effect?
No.
No body effect. You follow me or not? Multiply by.
VDS.
I'm still waiting.
VDD.
Huh?
VDD.
No. This one is now what? BQ. Initially it was VDD.
Okay.
It's no longer VDD. Did you get it or not?
Yes.
So what is it? V.
VQ.
Just VQ? Just VQ. Why? Because the source is what?
0.
Ground.
Grounded. VQ. No response. Did you get it?
Yes.
At equilibrium, I4 equal to what? I6? Yes?
Yep.
And when you do that, this is the equation you get. Can you tell me what did I substitute for VQ? Huh?
VT.
VT. Why? Because I want the cell to what? To switch. Did you get it? No response. Did you get it?
Yes.
Okay. This is not as straightforward as the previous one. Can you tell me why? This one depends on the process. Because one of them is what? NMOS, the other one is what? PMOS. By the way, you might tell me, where does this come from? Kn prime is what? COX, mu n. Yes? Yes? When you divide one, if you equate this, when you divide one by the other, you are going to only get what? The mu's. Because these will what? Cancel. Did you get it? No response. Did you get it? And one more time. Do you see BQ in this equation? Where is the BQ in there? The BQ is here. What happened here? Where is the BQ? I don't see the BQ. I want the what? I want the BQ to discharge all the way to what? To BTN or below, so that it will switch. Which transistor? Which transistor? Which transistor? M2. Did you get it or not? What M2 is it? Is a switch? What is the Q bar? Q bar will go to what? 1, which means the Q will go to what? 0, which means you have written a what? A 0. Did you get it? Yes or no? This is the right operation. I'm not sure, one more time. Did you understand why I only took the what? The right hand side? In the previous chart, by the way. I want you to see it. This one. What is this? That's the what? Left hand side. Yes? Yes? But I cannot use this. Why? One more time. Because the requirement is just the what? Opposite of the read. And since I sized it for the read, I cannot use it for the what? The right. Because I already sized it. Did you get it? So which one is this? Left hand side. Which one is this? The right hand side. I need to take the right hand side. The left hand side is already sized. Did you get it? Yes or no? No response. Yes or no? Did you understand that this one depends on the process? The process of fabrication. Whereas the previous one doesn't. Look at the previous one. This is the previous one. Why it does not? Because in here, both of them are what? NMOSes. Whereas the other one is NMOS, the other one is what? PMOS. Clear? Decoder we already talked about. Now, the what? The sensor. How much got time? Is this correct? Or is this the old time? Which means what? We still have an hour left. Okay. I'll explain to you next time. But let me look at the part. Do you see the top? The top. This one? What is this one? That's the SRAM cell. What goes inside the box? The back-to-back inverter. Did you get it? Good. What is this? That's the word line. What is this? The bit line and the what? Bit line bar. I want to show you, first of all, the pre-charge. Forget about the middle section. Look at the lower section. Pre-charge. What did I tell you a moment ago? You pre-charge both of them either to what? VDD over 2, all the way to what? VDD. In the diagram, he shows you what? VDD over 2. Let's see how he charged. This is VDD over 2. Yes. Connected to NMOS. NMOS. And there is a what? There is a positive clock. Yeah. You follow or not? That clock is only for what? Pre-charge. In other words, once the pre-charge is over, this clock becomes what? 0. Did you get it or not? So that this NMOS, this one and this one, stop what? Conducting. Clear? Can you tell me what is this function of Q7? Q7. You see Q7? First of all, did you understand Q8 and Q9?
Yes.
You didn't get the Q8 and Q9. You didn't get it. It's this high. Is this one on? So what is it? This is going to what? BDD over 2. And this is going to BDD over 2.
Yes.
Did you get it?
Yes.
But can you tell me what is the function of 7? Q7.
Level them out.
That makes sure that both of them are what? Are VDD over 2. Do you follow me or not? The balancing. He needs to make sure that what? This voltage, because when this one is on, what does it behave as? Short. Yes? This voltage and this voltage are what? Are the same. What does he call it? Equalization. Did you get it? No response. Did you get it? Okay. What remains is the middle part. Let me, a little bit before I explain to you the operation next. I want you to see the middle part. This one, This one, what does it resemble? This one is run by what? VS. This one is what? VS bar. And what is VS? VS the clock when you want the sensor to operate. You follow me or not? If you don't want the sensor, what is this one? Zero, which means what? This one is gone. And what is the top one? Q6 of why? Because if this one is zero, what is this one? And that's a PMOS, which means what? The sensor amplifier is out of the picture. Did you get it or not? When do you put it inside the picture? You want to put it when you want to sense the what? The back lines. Did you get it or not? I ran out of time. Next time I'll show you. You lost me, right? Did you lose me? We'll continue next time.